Calculating the timing of tasks is always easier if you have a diagram to look like. So anytime you have a verbal description about the relationship between tasks and when should one of them start or finish, always draw a picture. These short problems are a perfect example of that. Let's take a look. Task C has two immediate predecessors, task A and B. I would not go any farther with this problem until I drew that. Let me see. Task C is the subject. So I will draw a node representing task C. And what am I told? Has two immediate predecessors. They come before some task called A. When you are finished with A, you can proceed to C and B. So a similar diagram here. When you are finished with B, when A and B are finished, you can proceed with C. Now see, this gives us somewhere to store this other information. Task A has an early finish time of 3 days. A has an early finish time of 3 because that's where that would go on our table. And task B has an early finish time of 5. Okay, I think I'm done with the data. What is the actual stem of the question? What is the early start time for activity C? This particular question is an invitation to practice the early start time rule. Now, write it down if you have to, but it's best to be able to remember it. Let's rehearse. The early start time of an activity is equal to the largest of all the early finish times of its immediate predecessors. The early start time of an activity is equal to the largest of all the early finish times of its immediate predecessors. So here, in the case of C, we would be going back to look at the immediate predecessors, right, and we're just looking for the largest. One way to maybe help remember this is to actually picture the situation. C cannot start until A and B finish. That's what our diagram means. A will finish at the earliest in 3. B will finish at the earliest in 5 days. Right, this can't start any earlier than 5 days. That's the answer to that question. Now, the next question, you can draw the diagram again if you like as practice, but notice, let me just move it up here carefully. It's the same structure. Task C has two immediate predecessors, task A and B. Task A has an early start time of 3 and task B has an early finish time of 5. That's what we just drew right here. The only thing that's different with the next question is there's an additional bit of information. Oh, by the way, task C is 2 days long. Where does that go in the, I'm lazy, I'm not going to draw the whole thing over again. I'm just going to use our work. Task C is 2 days long, right there. What's the question down here? What is the early finish time of C? Oh, we do want to remember this basic relationship that the early finish time of a task, it's just logic, is equal to its early start time plus, I'm just going to write lowercase t for its task time. So in the case of this problem, 5 is when you can start it plus 2 days. If you can start as early as 5 days from now, you will be finished as early as 7 days from now. There's the answer to that second question.